Today I'm going to talk how to add Google Maps turn-by-turn navigation to Flutter applications. And a little bit about myself. I work as a lead developer and software architect at the CodeMate. Our team at CodeMate have helped to create Flutter plugins. For example, we have made features and new and a lot of fixes to Google Maps Flutter plugin. And also we have created Google Navigation Flutter package and Google Driver Flutter package, which is still private repository. And we have also worked with the camera windows plugin. First, I want to show some slides from the Google Maps Partner Program slide set, which shows that what Navigation SDK itself is. And Google Maps navigation and mobility services consist of Navigation SDK, Driver SDK, Consumer SDK, and the Fleet Engine, which is a backend service you can use with the navigation services. And what Navigation SDK does for your application? It gives possibility to navigate in your application itself. You don't have to jump to Google Maps navigation software or Google Maps in middle of user experience. It means that, for example, there are, of course, certain cases where this navigation is clear to be used, for example, delivery services and things like that, and ride-sharing services. But also, for example, if you have applications which have closest doors, for example, you don't have to, developers and users don't need to go to different applications when they want to navigate the closest door. You can do that inside the application. And that helps a lot as a user experience in general. So there are a lot of use cases where this navigation could come part of your application, even if it's not clear at the start. And what their services does in the background, it keeps automatically route optimization, and it always knows what the traffic is at the time. Instead of just fetching the route from the route API and use that as a map and show the polylines over the normal map view, this is real time and it shows the changes on real time on map view. And also, if you want to use Driver SDK and Consumer SDK and the Fleet Engine, it allows the companies to see where the drivers are driving and to find the best driver for each route and ride-sharing case. And also delivery companies will use this quite a lot. And those were like official slides from the Google set, and now we start with the presentation and what it contains. So first we will go through how Google Navigation Flutter library works and what it is and how it has to be set up for your Flutter project. And then we check how to control the navigation session, listening the navigation events, and customizing your navigation UI, how to implement Android Auto and Apple CarPlay support, and also we go through how the Driver SDK works. And then I go briefly about the package development itself. So, navigation library for Flutter is currently working with Android and iOS. Those are the mobility services provided by Google. currently Navigation SDK is available for those two platforms. It's in the beta, our plugin, and it's under active development. There won't be much like breaking changes, but we will bring some features which are still missing to the library. And features which Navigation SDK has, you are able to control the navigation even without map view. This is really important, and that some cases you want to navigate in your software without showing the map at the same time. There might be places where you initialize the application and the navigation session starts immediately, even without map. So it has to work as a background. And it supports both navigation views and the map views. So this also implements same features than Google Maps Flutter library, which is official Google Maps library made by a Flutter team. You can't use Google Maps Flutter at the same time with this library. This is because the native library of Navigation SDK overrides the Maps SDK library, and there will be like a collide with the classes. So if you have already Google Maps Flutter in your software, you have to replace those functionalities with this library. But this brings almost the same features as the official Google Maps Flutter package. This supports turn-by-turn events listening. It means that we can listen those events in the application and use that information to do choices on the application layer as well. And for development purposes, this is really important. It allows to simulate the user location and driving the route with certain multiplier for the speed. So it's much easier to test with simulation than going to walk in the outside and test the application. We have support for CarPlay and Android Auto, which allows to show the custom navigation screen and your application implementation on the CarPlay and Android Auto screens as well. And this has support for driver SDK extension. It means that we have exposed certain navigation libraries in the native layer that driver SDK can then take care of and connect to. And next we go to the setup, how to add the plugin to your Flutter application. It's very simple, but let's go through all of these steps. So first you have to create or use your existing Google Cloud product in the Google Cloud Console. You have to enable the Navigation SDK API separately. You have to create API keys and restrict them to your app platforms. And after that, you have to have billing enabled. Navigation SDK features aren't like they are billable features, which come in the case when you have a lot of requests to the Google services. First, you don't need to add other dependencies than this package, and always read the README file because it has a lot of setup instructions, but let's go through those in this talk as well. You have to put the Android API, Google Maps API keys. You should have separate key for Android and iOS for security. Don't write those directly to the metadata. It's not a secure way to do that. Instead, for Android, Google has secret Crandall plugin, which can be used to manage security keys. And in the CI, you just update the key on the build phase to the local local settings of the build file for Android. And for Swift, you have to provide the API key in the app delegate, and for that you should find also a secure way which fits to your own development process to pass the key for this method. And some extension, if you target the older Min SDK version for Android, you have to add desecuring for Java 8 support. The build will say about that if it's missing. So the README file has good instructions how to add this desecuring support for the Android builds. And also iOS, you have to ensure that you have right UI background modes selected. Location as the most important to support background navigation. And but permissions, you should use Google Flutter's permission handler package to do this, and you have to have location when in use permission at least to make this work. But after that permission is given, you can ask location always permissions, which allows also the background process of the navigation guidance. And next step, what you do with the plugin after all these how to initialize the plugin, you have to accept official navigation SDK permissions. First time user uses the application, you should show this terms and condition dialog. If it's not shown, it will throw error if you start to initialize the SDK or try to start the guidance. So there are separate methods you can use. You can check if the permissions are accepted, and if they aren't accepted, you can request the dialog. And there are some options how to modify this dialog, and they will be published soon in the SDK plugin as well. Currently, you can change the title and the company name, which is visible on the dialog. And also, there's an option that you can only show the driver awareness disclaimer. But this is not available for all the customers. This is something that you have to talk with the Google team to make it available for your application for driving security reasons. And to initialize navigation, you just call initialize navigation session method. What happens on that time if you have Google Maps navigation view already in your widget hierarchy? It automatically binds that to this navigation. In these snippets, the first one shows how to initialize the navigation. There's one option over there which tells what to do when the application goes to background. There are a few options. You can quit the service. It means that when you close the application, the navigation stops as well. But there's also option to put it continue mode, which means that even if you close the application, it keeps the background process running and the navigation is running. And if you open the application again, you can continue the navigation process. So there are places where you want to keep navigation running when you switch the applications or don't want them to be killed in the background. So then just put this task removed behavior to continue mode. And in the next snippet, you see how to add the Google Maps navigation view to your application. We currently have a method that have on view created. It's a similar method that is used on the official Google Maps Flutter plugin, and it returns the view controller. It has methods like you can enable your current location, and you can control camera with that, and like, for example, animate camera at different location and things like that. This is something that we will change in the future. Instead of waiting that the view is ready and having the controller, it would be much better that you can create the controller first, and it's the required parameter for the view. So it allows us to create the view in the background before the platform view is really created on the plugin layer. And it also would help then to, for example, you can set some listeners before the view is even rendered. It would be really helpful. So that's upcoming change. But currently, the controller is given in this phase, and it's working fine this way as well. But improvements are coming. And as I said, when the navigation session is opened, the map automatically connects to that session. But that can be controlled on this Google Maps Navigation view. There's an option that what happens when the map is opened. Should it connect to existing navigation session, or should it be disabled on the start? So you can make it so that it looks normal map, and you can enable the navigation view later on with the controller. So next thing, what you normally want to do with the navigation is set the destinations. You can use few ways to set the destinations. First one is to use the place IDs. And I have to say that you don't have to put only one waypoint. You can put multiple. It's a list of waypoints you can put to your right. You can use place IDs or targets, well, locations of the places waypoints you are targeting, and those are given in the latitude and longitude version. This shows in the example the city cube as a waypoint, and also when you start the navigation, set the destinations, you should give the display options and should it show traffic lights, stop signs, and also how to show destination markers on the map. And the routing options, that's really important. You have to tell which way you are driving at the moment. There are options like bicycle, driving, taxi, motorcycle, and things like that. And that affects how the view is looking, and what route it will find for you, your session. And the next important step is to start the guidance. And when the guidance is started, okay, it doesn't show the video for some reason. Yeah, now it started. So when you start the guidance, it starts to animate automatically the map, and these all are processed by the library underneath the native library. And as you see, it has like a header and footer. Those are coming from the SDK, and they are part of the view. And I'll show later how to modify these and create custom ones. After the guidance is started, you are able to set the simulator on the debug phase. Of course, in the real application, you don't use simulator, but here it's really easy way to test your application. And there are also methods to stop the guidance whenever you want. And also for the simulator, there's pause and resume, and there are few options how to simulate along the route. Just check the documentation and you find all the other options. So next, about navigation events. These are really important. You should always listen when you are arrived, so that you can do some actions on the application. Normal action on arrive is to stop the guidance, and you get on arrival event each time you are at the waypoint. So when you go to the next waypoint, it doesn't continue to the next waypoint if you don't update the destinations. So when you arrive to the waypoint, just remove the one waypoint from your destinations list and call set destinations again, and it continues to the next target. And there are cases when route changes. For example, you can Navigation SDK can give you multiple options for the routes, like as an official Google Maps application, and the user can click different routes, and every time that happens, this on route changed event happens, and you can do actions on that. One action on this case could be that you just fetch the current routes from the navigator. You can get current route or all the routes for all the waypoints and all the route legs. And you can do something with that data, analyze that, or find even change the route if it doesn't look right for your application. And then there are methods to read the current location. Google has a separate API as well to get road snapped location. It means that if you give the coordinates, your real coordinates for your user, it snaps to the right closest navigatable road. So the location this gives is not the user's location, it's the closest road, and it can be used for several reasons. And one good way to start the navigation is to wait this event to happen, and so you really know that user has location before you start the navigation. About custom navigation info view, there are a few ways to modify the UI. All those components which are visible over the map, you can hide those with the controller commands. For example, in the image you can see this ball, which can be used to report, for example, accidents on the route. That can be hidden as well. You can hide buttons and things like that. Also, you can hide the header and footer as it's shown in the snippet, and you can use these few listeners to have those same data you can normally used on the header and footer, and create your own widget to show those same information. In this example, I have listened the nav info events, and you can use that to render that header. It gives you a lot of information of the next target. It gives you the maneuvers you have to do next. It gives you distance to next intersection, and a lot of data about the road you are driving and so on. Also, you can use listener to listen remaining time and distance to the next waypoint. and that information is quite informant also for the clients. This allows you to create change the overlay look and make it more for your fitting for your own application. And one important area on this is that you can put map padding, which allows you to move all these components which are overlays on the map, so that they don't being drawn under those elements. For example, in this view, I have top padding about 400 pixels, and it moves this compass icon under the header view. And also, this supports all the basic map features, camera controls, map styling, markers, circles, polygons, and polylines. So you can do same things with the Google Maps Flutter plugin. And as said earlier, you can create map view, and if you create map view with this package, it doesn't have any navigation view elements on it. So there are cases that when you start navigation in your application, you might have separate page where you want to show normal map without any knowledge about the existing navigation process. So that's doable with that. About Android Auto and CarPlay support, there's a short video example of the Android Auto example. There's a tools that you can open separate screen on your desktop and simulate the Android Auto view. And as you see, we have some custom buttons over there, recenter button, and there was a custom message sending feature. Those are made by us, giving you way to extend our Android Auto base screen. So our library gives you native components for Android and iOS. These are native code, so if you want to do create Android Auto support or CarPlay support, you have to write a little bit native code. This is simplest way to do that. You don't have to actually override the on get template, because the base view does that as well. You have to just register a few views on the native side to get it working. But the reason why we made this way is that there are in every use case you have to create different kind of templates for the Android Auto screen, and we don't just have ways to do those layout on the Flutter layer at the moment without doing a little bit extra work which is not related to this plugin itself. So it's quite simple to do those templates. So having upgrading this, extending this base screen is fairly simple, and there is way to call the native Flutter layer from the Android Auto base screen, and there's support for that. And then we made possible to extend this navigation package with driver SDK. How it works, you have to have access to Google Driver Flutter plugin. You can get that from Google Maps Mobility team, and it's currently private, but access is available for those who are in need. And When you use this, you don't have to have Google Navigation Flutter dependency, as this package has internal dependency to this Flutter, this package. And our navigation SDK internally exposes internal native libraries and classes and session for this driver SDK. So these packages are communicating in the native level. And there's an example how we have done this in the native code. This is Kotlin code, which does fetches the Google Maps Navigation Session Manager from the navigation library and gets the instance and in it finds the navigator, which is then passed for the driver SDK. This is something you don't have to touch yourself. This is just an example how it's done in the background. And the driver SDK itself, you use that as a normal navigation SDK. You do same things we saw earlier, but in addition, you initialize your driver session with your vehicle ID, which you get from the Fleet Engine backend. And I have few examples how the driver SDK works. So you have scheduled tasks, which is for delivery services. And there's a separate view which shows the data from the Fleet Engine. And you can see the vehicle moving over there. So this is something which is used for example, services that have a lot of drivers for delivery purposes. And then I have an example of on-demand trips. These are like ride sharing. If you think about companies, taxi services and things like that, this is from them. You are able to use the consumer SDK separately, and the consumer sees where the driver is driving when this is used. So this is a bit about our development process, which we felt really important when we created this SDK for Flutter. And we wanted to have unified API across platforms. It means that you don't ever have to do like a check if it's Android and iOS. Even if the native SDK had some differences, we have unified those so that in Flutter layer it always works same way on the Android and iOS. And about documentation examples, we felt really important that every public API which is visible for Flutter developers are documented. There are internal examples in those documentation as well. So if you check the documentation, it's quite easy to find out what these functionalities do. And for example, in the controllers, it's easy to check what to do with those functions. And we have fully featured example application. It means that every feature which is available in the application is also in the example application. If you start the example application with your Google Maps API key, you can test everything which is available or the plugin. And there are quite a lot of features which we didn't cover this time. And the test coverage, all the features which are testable in the integration test are available and tested. Testing the library, if you have navigation features in your application, it's always tested against real world data. So if you have integration tests which have navigation, it really checks the real time if there are traffic and things like that. So it might cause flaky tests if you select places in the test cases which might have roadblocks on something. So select those places carefully and select the places where you want to run integration tests for navigation. But it's underneath it tests this library instead of your application. So select carefully what you want to test on that area. And for code quality, we have everything is of course linted and reviewed. About the documentation, there's official documentation in the pubdev of this, and every class has really well written documentation, so it should be quite easy to implement that with that documentation. We have separate categories in the documentation as well. Some functions which are available only for map view and some for navigation view. Those are clearly marked in the documentation as well. And there's an example application. You can see, as I said, it has all the features, and it's available in the example folder in the package as well. We can check the video for a while if you want to see what kind of features there are. As an example, you can see you can change the driving method easily in the example application and test how it works. And if you have any issues implementing this navigation SDK to your application, it's easy to go to example application and check first that does it work over there. And if it does work over there, you can easily check how it's done and use that as a base. So we haven't had a lot of issues on this package related on this how to implement things. So I have seen that this example application has been a really good thing for developers. And this is a little bit about our plugin development in general, and also in the Flutter plugin development, which has been a big part of the package of this process as itself. So if you start to do these kind of packages, it's good to follow official Flutter repo style for guides. There are really good style guides and really good rules how everything has to be documented and created. And if you follow those, quality matches quite well with the latest work Google has done with the Flutter team. And that's all. Thank you. It was nice to talk what we have done. And if you have questions, please ask.